For a very long time now, people have been wondering about life in Venus, but ever since the focus had shifted to life in Mars, Venus has been out of sight to the public. But there has been significant advancements in the studies related to Venus. Hey people, welcome back to our channel. In today's video, we will be looking into everything you need to know about the latest discovery on Venus over 8 years of changes. But before we start, make sure to subscribe to our channel, turn on the notifications, and most importantly, watch the video to the end. Now let's get started. The Venusian clouds have an odd thing going on. A layer of the atmosphere well above the planet's scorching surface has been found by telescopes to have exceptionally high amounts of the molecule phosphine, a foul-smelling combustible substance typically connected with excrement, farts, and decaying microbiological activity. The discovery is puzzling because the phosphine is almost everywhere connected to life on Earth, either as a byproduct of physiological processes or as a consequence of human interventions like industrial fumigants and methamphetamine manufacturing facilities. The chemical has been chosen as a potentially unmistakable evidence of life while being poisonous to many creatures because it is so difficult to produce through normal geological or atmospheric action. Venus is a terrible world covered in sulfuric acid clouds with oppressive surface pressures and temperatures hot enough to melt lead. However, the specific cloud layer containing the phosphine is relatively warm, with plenty of sunlight and Earth-like atmospheric pressure and temperature. The scientific community will need to carefully review the findings. However, they seem likely to rekindle curiosity about visiting our neighboring sister planet. According to Michael Wong, an astrobiologist at the University of Washington, it is a really intriguing discovery since phosphine doesn't fit with our understanding of what kinds of compounds should be in Venus's atmosphere. Sanjay Lemay, a planetary scientist at the University of Wisconsin-Madison, concurs. The fact is, he argues, we don't know what's going on. Venus is the brightest object in the Earth's sky that can be seen with the unaided eye after the sun and moon. People have been relating legends about the brilliant jewel that appeared at daybreak and sunset for countless years. The brilliant nature of Venus appealed to radio astronomer Jane Greaves of Cardiff University in Wales. She usually concentrates on faraway young planetary systems, but she wanted to test her chemical identification skills on planets in our own solar system. Using the James Clerk Maxwell Telescope on Mauna Kea in Hawaii, Greaves studied Venus in 2017. He was looking for barcode-like patterns of lines in the planet's spectrum that would point to the existence of various substances. She spotted a phosphine-related line as she was doing this. The findings revealed the chemical was present in the planet's atmosphere at a concentration of 20 parts per billion, which is 1,000 to 1 million times larger than that of Earth's atmosphere. Greaves admits, "I was surprised. A relatively straightforward chemical phosphate has 3 hydrogen atoms and 1 phosphorus atom. Although by the time it reaches quantities where people can smell it, it is likely to cause lung damage. It is known to smell like garlic or rotting fish." Walter White, a character on the television show Breaking Bad, mixes phosphine gas to kill 2 attackers who are threatening him. Making the substance, however, is more difficult than what is depicted on television. According to Clara Souza Silva, a molecular astrophysicist at the Massachusetts Institute of Technology and co-author of the study that reported the phosphine discovery, phosphorus and hydrogen hate each other. Phosphorus would rather connect with oxygen, and hydrogen has much better things to do. But in some settings, they can gather together and be stable if you apply enough energy to them. Because of their hot innards, the gas giants Jupiter and Saturn contain phosphine, which can be produced under certain conditions. By contrast, oxygen-containing molecules, such as carbon dioxide, that would typically absorb the phosphorus in phosphine, are abundant in Venus's runaway greenhouse atmosphere. It was quite puzzling for the chemical to be present at any level, much less the ones Greaves was observing. Sousa Silva, whose Twitter account is @DrPhosphine, has made a career out of researching phosphine and speculating on how it might manifest itself in the atmosphere of an extraterrestrial planets in the distant future. "I was thinking of these far-off exotic worlds like super-Earths, tropical planets, and sewage planets," she continues, "and I was right here next door the entire time." Using the more potent Atacama Large Millimeter Submillimeter Array in Chile, the researchers and their colleagues repeated their studies of Venus last year and once more picked up the phosphine signature in the atmosphere. After that, they tried to think of every explanation for the existence of the odd chemical, including volcanic eruptions, lightning strikes, and even meteorites fragmenting in the planet's atmosphere. The best routes we could uncover, according to Greaves, fell short by a factor of around 10,000. Of course, the team has not yet considered any further routes for producing phosphine. The molecule might be produced by life on Venus, just as life is the primary way it appears on Earth. But after exhausting all abiotic possibilities, the researchers were compelled to admit this possibility in their work, which was published today in Nature Astronomy. Astrobiologists have long been fascinated by Mars since it is a dry, stony planet with environments that are not all that distinct from Earth's. More recently, icy potentially habitable worlds in the outer solar system, such as Jupiter's oceanic moon Europa and Saturn's geyser-emitting satellite Enceladus, have captured their attention. Venus has several disadvantages, but scientists who are making predictions about the locations of life on other planets have not wholly ignored it. There is an atmospheric layer between 50 and 60 kilometers above the surface of Venus with a pressure comparable to sea level on Earth and temperatures ranging from 0 to 50 degrees Celsius. If the sulfuric acid clouds weren't there, this layer may be described as hospitable. However, there are some terrestrial creatures that can happily live in hot springs or other settings with such severe acidity. It is this pretty pleasant area where the phosphine has been discovered. Astronomers have also noted since the 1960s that Venus's clouds are not reflecting as much ultraviolet light from the Sun as they should be because of an unidentified component of the atmosphere appears to be preferentially absorbing that radiation. The late astrobiologists Harold Morowitz and Carl Sagan suggested that energy-hungry photosynthetic organisms might be to blame as a result of this observation. Other researchers, meanwhile, never gave up looking for further abiotic answers. Recent data indicates that the planet's geology is still active, and a model unveiled earlier this year suggested that Venus may have had an ocean for almost 3 billion years that only recently vanished. It is possible that life existed on Venus when it was much more like Earth and only moved into the atmosphere when the runaway greenhouse effect made the planet's surface uninhabitable. David Grinspoon, an astrobiologist at the Planetary Science Institute who is not involved in the work, affirms that he has always believed the possibility of life being in Venus's clouds is just as likely as the discovery of life beneath the surface of Mars. Every environment has the potential to support life, but this isn't a given. However, there is almost identically strong arguments that Venus's clouds are harmful to life as we know it. Although microbes have been discovered floating in the atmosphere of Earth, it is unknown whether any of them spend their whole life cycle there. They must all land someday, and Venus's surface seems too hostile to serve as a suitable reservoir. The Venusian region being studied is also 50 times more arid than the Atacama Desert in Chile, which holds the record for being the driest location on Earth. While it is true that life has successfully adapted to exist in aqueous environments that contain traces of sulfuric acid, the conditions on Earth's evil twin are practically the opposite. The majority of its cloud layer is composed of sulfuric acid with a very small amount of water. Venus is still mostly unexplored. It's literally the planet next door, yet there are still a lot of secrets according to Wong. Researchers will need to discover a great deal more about the planet itself, including its chemistry, geology, and atmospheric physics, he adds, in order to rule out all non-living theories for the formation of phosphine. The detection of phosphine may also be a problem. The team's data had noisy ripples superimposed on Venus's spectra, making it relatively difficult to resolve any individual line. According to spectroscopist Bruno Bézard at the Paris Observatory, these wavy formations potentially resemble a phosphine signature. Greaves responds that it is statistically unlikely to discover the same signal using two different facilities, JCMT and ALMA. To further validate these preliminary findings, she and her colleagues plan to conduct additional observations at various wavelengths, such as infrared. It may also be possible to link the phosphine to biological processes by creating high-resolution maps of its distribution and checking for seasonal variations in its appearance. The surprise discovery resembles the 1996 report of possible microscopic life in an old Martian meteorite known as Allen Hills 84001 in many aspects. The sample also contained structures that resembled prehistoric bacteria and a particular type of iron crystal that resembled those made by microbial life on Earth. Years passed before scientists could come up with an inorganic explanation for these crystals. Even though life did not work out as an explanation in that situation, Grinspoon claims that it got everyone thinking. Well, why not? This video has come to an end with that. Let us know your ideas in the comment section below to help us expand our community and attract more people who share our interests and who are eager to learn. Please hit the like button and subscribe if you thought the video was interesting. Till then, bye!